Good afternoon. Thank you so much for inviting me to talk about some of the work that we've been doing jointly, cooperatively with NDOT. I'd also like to acknowledge J2RP, which is our research arm that connects the University, Purdue, with NDOT. So let's talk a little bit about development and implementation of this bridge deck preservation program. So I think many of y'all are familiar, just wanted to kind of have just a little introduction about the crack and deck sealers. So when we have a bridge deck, one of the common things that you see often is not just a flexural type crack, but you get through depth cracking. This is primarily due to restrained shrinkage that occurs in many of these situations. We've actually done a lot of work with NDOT to actually also improve that, and we've done considerable work that has already been integrated into the way that new decks are designed. But we obviously have a large inventory out there of existing decks. But what we get are a few ways of trying to repair and seal these decks. So one would be to have a localized crack sealer. So you can see here a gravity-fed product would be very beneficial for us, that we could easily apply that type of material to localize the cracks. And I should say is while we're looking at existing bridges, we also believe that this is a preservation that starts from the beginning. And I've heard a lot about that you can't look at it as just 15 years later we have a problem we want to start trying to remedy. We look at new deck because these through depth cracks are still going to occur in our new decks. So we want to start mitigating right from the beginning to protect the deck for the future. We also looked at penetrating deck sealers as another procedure, because at the cracks we have one technique, but we now want to also seal the chlorides out of the rest of the deck. So obviously what we want to do ultimately is reduce saltwater ingress because of corrosion of the rebar. So if we have some alternative products like glass fiber bars I heard some discussion about, or stainless steel, that may not be an issue, but when we're looking at our normal bread and butter type reinforcement, this is definitely an issue that we want to prevent either the chlorides, obviously moisture, and oxygen if we can, out of the deck. So let's talk a little bit about the specimen. So we wanted to look at a bridge deck representative. So you can see here, this is our specimen. These are macrocell specimens. I heard a little bit earlier about the issues about the top mat versus the bottom mat, because epoxy coated was originally put at the top, but then you had a problem when you have that dissimilar connection occurring. And so research actually that was done a lot at Texas when I was a grad student recommended that we no longer have that mix of reinforcement, the epoxy in the top and the bottom. We have to use both as epoxy. So these are macrocells. These were cast in 2010. It's a little modified from a standard ASTM macrocell. We wanted to represent a bridge deck. These are 8-inch thick, representing the deck. They are sealed on the sides to have continuity, but more importantly, they actually have a mat of reinforcement. You often would see a macrocell that just has a single reinforcement bar, but we have mats that cause electrical continuity, and also at the crack locations, we're getting a longitudinal bar because the cracks love to find those bars. That's where the crack occurs. So this is the specimen. One other thing is we actually have cracks in decks. So some people have done research on macrocells where it's uncracked and it's not representative of what we have in the field. So we actually crack these specimens. So if you take a look, when you look at that macrocell in the middle, we actually loaded the bars and we stressed it to cause cracks. So in the geometry, it was designed to cause 3 cracks. So 3 cracks generally would form. Every once in a while, we caught a 4th crack in the cracking formation so that we had cracks to repair. So those were cracked. It says 60 and 90. We also did want to look at specimens that would be between the cracks, so there would be no cracks in it. And then we would repair it with the different products that we were looking at. We had a whole study that was done before this that looked at and evaluated over 200 different products, and we narrowed down to some of the products that most were used by a survey of many of the states, as well as what NDOT had some experience with. But one more thing is some studies that actually looked at some of the repair materials, but they never re-stressed them. In a real bridge, we're going to have shrinkage, we're going to have temperature effects and loading. So we actually, after repair, re-stress to 2/3 of the yield stress, or 40 KSI, to simulate stresses that the materials would have to accommodate so that we don't we'll know whether that was actually just filling or was it actually bonding to the surface of the concrete to give us better performance. So those applied stresses were reapplied. So here's the testing. You can see all the different macro cells. We pond them with saltwater solution just as a standard macro cell type test. We do a 2-week exposure, wet and dry, so 2 weeks wet, then we go through a dry cycle, which then feeds the oxygen back through. So it's an accelerated test, but is representative of what we see out in the field with these bridge decks. This was exposed, interestingly enough, to 1,600 days. So this is one of the longest studies that's ever been done. Usually you get the life of a master's student on these projects, which is about 1.5 years. We actually had the good work, again, working with NDOT, that we extended this project for multiple years. So it went over about almost 4.5 years of exposure to really determine what was going on. Then we'd autopsy the specimens at the end. We actually did an interim autopsy as well as one towards the very end of at the very end of the project. So we would open up the specimens to see what was going on visually. But we also, again, had electrical measurements. I mentioned the macro cell, so we have a resistor that's measuring voltage drop across it so that we can now monitor over time what was occurring. So to show you some of the crack sealers, so these are 3 of the products that we used. We had a couple of low viscosity epoxies that had worked very well for us in the past. We also had a methacrylate. Depending upon the width of your crack, one may be more suitable than the other. So those were the products we're looking at. And let's look at the electrical data. So this is the total corrosion, so the total accumulation of electrons that pass from the top to the bottom mat. So when it drops down negative here, we're showing it actually it's corroding at the top and it's feeding the battery to the bottom. So you can see in the control specimens which are shown, and so these are the control specimens that you're seeing below. You can actually see that when a cracked specimen, corrosion starts essentially at day 0. Because the crack is there, it's allowing the chlorides and the moisture to get right to the reinforcement right away. So we can see that we actually had some autopsy here, but in the crack sealers that we had here, you'll see that that line is staying pretty much at 0 the whole way. So these crack sealers can be very effective. In fact, they were very effective. We actually did have one of the products, which is shown as number 20 here. I have pointed an arrow there to it, and if you see that one that did drop off. So we had on this master seal that we did have a localized failure in one, and so we were trying to figure out what was going on there, if it was the product or not, and we'll take a look at that in a little bit. But in general, only one specimen. The other 2 went down to where we had no problems with it at all. When we look at that specimen, you can see at each crack location, we actually did get corrosion. So that one failed in 3 locations. When we were looking back after 1,600 days, we went back to what we did here. We had several different students throughout the duration of the project, but this Master Seal 630, the methacrylate, has viscosity similar to water. And the way that they were repaired, they tried to continue to fill the cracks up for that product. But there is this masking tape that was held on the side to hold the product in. We feel that we actually did have some loss in that one, but the other 2 worked perfectly throughout the duration of the test. So we may have had some loss in that one specimen. If you look here, this is an autopsy. We actually created a ranking system of where the damage was to develop a scale of how much damage that we had. And you can see for the 3 products, the Secador, Durell, and the Master Seal, all of them did very well. The blue is how much damage was inside of the specimen. The red is that we had some corrosion outside. We had to continue to seal those specimens. So if you had corrosion right at the surface, that was discounted because that was part of the exterior of the exposure in the room, not part of the inside of the specimen. But we wanted to document all of that corrosion on the bar, so that's what the red is. The control, you can see how dramatically the difference the corrosion is. So these products worked very well for sealing the cracks. Let's talk a little bit about deck sealers. Now this is in a cracked specimen first. So we actually use the same deck sealers whether I had a cracked specimen or uncracked. So you can see we had a solvent-based 40% silane, water-based 40%. We also had linseed oil. Turned out that historically many states use linseed oil. So So we looked at that because there was supposedly very good performance we'd heard about, so that was added in here. One thing I just wanted to mention at the bottom is this Master Protect at 40% silane. Because of some environmental changes in the state, we started out where that was a viable product. That changed, so as we went and finished our project, no longer could that really be used in the state because of the VOC content of that product. So if I'm taking a look at the deck sealer, so let me say is you're going to see in this one failure across the board of the deck sealer, but these are crack specimens. Someone had the idea, and we've heard this before, oh, I just flood coat the whole thing and that deck sealer is going to prevent the corrosion at the crack locations too. I think you can see here it doesn't. In fact, one you see positive, that means that the bottom bars were preferentially corroding versus the top bars, which gives you a reverse macro cell that normally you get with the top to the bottom, and that's why you're seeing that bar to the top. So we had significant corrosion in all these cases of all the products when it's cracked, so make sure to understand that. Let's talk a little bit about this though. So now we use that with no crack repair, and when we open the specimens up, you'll see that the entire inside was damp. We never saw that in any of the other specimens. Those silanes, the seals were actually preventing moisture also from going out, and in some cases we had higher corrosion rates with these than we had when we didn't even have a sealer. So I thought that was an interesting finding. But it stayed moist for an extended period of time. In fact, we didn't open them up right away, and it was still moist inside of these. So if we take a look at this one, this is now a crack and deck sealer. So we sealed the crack and applied the deck sealer. And if you look for the first three, you'll see just the red bars, there was no corrosion at all inside of any of these specimens. So the combination of using the deck sealer and a crack sealer worked excellently. You can again look at the controls at the very bottom, G11. We had extensive corrosion in those. Now we did see, if you look at G10, the very bottom one shows a blue bar, and this was the Master Seal 630 again with the other product applied. We had a localized failure again of that Master Seal 630, and I can show it to you. So again, we had great performance really for the combo, but here's that one inside after autopsy. You can see two cracks worked perfectly. We had no failure. It was a localized failure at one. So again, we may have had that same leaking that occurred before that we experienced in one of the other specimens. Now again, this is a methacrylate, which I like to use those for thinner cracks. These cracks were in the order of 0.02 inch. Okay, so it gives you a scale of how wide the cracks are that we're trying to repair. Let's talk about the uncracked specimens. So our test variables were a few things. One is deck sealer only, so these are uncracked. So we're looking at between the cracks, if you will, in a bridge deck. So deck sealer only. We also wanted to look a little at surface prep because a lot of different products are recommending, do I sandblast, do I do things to prepare the surface? We were trying to make things minimal. If we don't need to really sandblast and do a surface prep, that would be preferential to us because of the cost involved of doing that. So we wanted to look at that. So we also had these in this case of sandblast them and then seal it to see if that was any better than just having a tine surface or actually just having a smooth surface. Simulated traffic where we sealed it and then sandblasted off a certain surface, which simulate traffic wearing off the sealer. So just to give you a quick summary here, deck sealer only, over 1,600 days, all three products, no corrosion observed at all. Surface prep, we saw no corrosion in any of those. So either I surface prepped or not, we had great performance in both. So we're not recommending surface prep. I mean, when I say that, we don't want to have a dirty deck. We want to clean the deck, get material out of the cracks if you have cracks, but we don't feel from our test that we need to have a surface prep. Traffic wear is another story. We need to talk about that. So let me first show you the results here so you believe me here about the results. So you see the control specimen, how it started to corrode. One thing you may notice here is it took 600 days. This is an NDOT Class C concrete. It took 600 days before we actually got any corrosion down to our normal cover. So it took about 2 years. That was part of the study why we had to go so much longer too. It took 2 years before we got any corrosion occur even in the black bar. Once we got the corrosion initiated, you see it start to take off, but all of the seal products up to 1,600 days, no failure. Traffic wear, we did it. The goal was a 1/16 inch to simulate some traffic wear. This is much worse than some of the traffic wear maybe that you may see in terms of the abrasion, but we sealed it. okay, and then we took and blasted this off. So this was estimated to be somewhere at a 1/16 of about 10 years of wear on the surface. So if we take a look at this, first thing maybe to note is if you look at the line that's the furthest one down, the one that's dropping quickly, it took about a year, a little over about 350 days. So actually by taking off that surface, creating more porosity, it allowed for the chlorides to get down quicker versus the 2 years, 600. You can also see as you get further out, now we're starting to get failures of all of the different products. A few hung on to the end. So let's take a look at that summary. If you look at the first one, you'll see one specimen had no corrosion at all on the Master Protect 448Z. You had one that had a little bit of corrosion on it, and we attribute that as probably to how much surface. It was not a perfectly controlled process sandblasting, so one may have gotten a little more of the surface of the other, but we do eventually get corrosion developing. You'll see that in also the H400. Linseed oil, surprisingly, no corrosion in either one. So linseed oil performed excellent in all of the study. You can see the control that's down below. Let's talk a little bit about chloride penetration. So this is now uncracked surface when we had the different products. So on the black bars that you're seeing to the far right, that's the chloride levels that we measured. You'll see there was 2 levels that were done at 2013 when we opened up some of the specimens, and then we again opened it up in 2016, so 3 years later. You can actually see that the chlorides hit fairly high at the level of the steel. They increased in the black bar over time, which you would expect as we continue to get chlorides in. But if you take a look at all of the ones that are sealed, we had no change in chloride levels from 13 to 16, showing the effectiveness of the seal. So the sealers were effective. In fact, all the levels that you see there are indicative of not chlorides getting in, but that's the natural chloride level of the concrete. We measured without any chlorides, and that was the chloride level that you're getting inside of just the concrete on its own. So it was very effective in all cases. So just to get to some conclusions here is using only a crack sealer. Crack sealer, they all work very well, but you have to consider that corrosion will occur between the cracks, so you can seal there, and we started to see that at the end of our test that we did get where now we start picking up some corrosion even when they're sealed because they're getting chlorides down in between the cracks and hitting the level of the bar. So you can't just say I'm going to seal the cracks. As I mentioned, and not to pick on an individual product, but the Master Seal 630 was, we believe, sensitive to the installation here because of the width of crack that we had and the fact of the way we were sealing that off. In a bridge deck, you obviously have a better, but you might be losing product underneath. So you need to make sure that you seal that. If it did get filled and hold, it actually worked very well, but we did have a few failures. Only a deck sealer in cracked concrete, again, so cracked, and trying to use that to seal and fix my cracks, it doesn't work to seal the cracks. In fact, we saw it could prevent the water from evaporating. We had a few cases where the corrosion was worse than had we not even sealed at all. Using the combination is what we recommend, that you need to seal the cracks, you also need to seal the entire deck. So we had excellent performance across the board, with the one exception was, again, that 630, where we had one localized failure, probably due to installation. Traffic wear obviously reduces effectiveness because you're taking off that level of product, that level of thickness of the membrane that you have essentially that's developed. And so we feel that resealing on a regular interval is needed, and we'll talk a little bit more about that. You can't just apply it and say it's good forever. There is, because of wear of the surface, you're going to reduce the thickness of that product being effective. Deck sealers effective in uncracked concrete, as I just mentioned, is that the chloride levels remain the same over the entire duration of the 1,600 days, and we were still at the base levels that we saw. They were the same as with the concrete. So we were not gaining chlorides inside, meaning that it was being very effective, not transporting the chlorides down with moisture. So let's talk a little bit about installation. So again, in our partnership with NDOT, we wanted to not just say we're doing this in the lab, we want to get out in the field and also come up with some techniques that could be applied very readily by the personnel in the districts. And so what we worked was coming up with a crack sealing technique of installation, and you can see here one of the ways that we developed. So we worked with some pumps. You may have seen some of these that are used to seal cracks and other kind of installations. So with our two-part epoxies, we need to make sure that we don't just make a pot that starts to go bad over time, that we have a certain pot life. So in this case, we actually have what's shown on the nozzle is where the mixing occurs. It's just a plastic nozzle that you throw away, and many of you may be familiar with this. But we can also heat up the tanks to keep the epoxy at the right temperature, and then we can salvage all the way until we hit that nozzle anything that we're not using. Because the materials are not the cheapest, we can actually recover all that material and not have waste. The second is just from the back breaking. We have seen some states actually that are mixing in a pot, essentially, or putting in a squeeze bottle, and they're bending over trying to fill the cracks up. That's not a way to do it effectively on our bridges. So I understand right now we've done one, I'm saying Jeremy, over about 100 bridges I hear what we've done through the district, something like that. So we're deploying it through there. We bought the equipment originally for the research, donated that off to NDOT, and then NDOT started to use that equipment for this. The next one is just talking about deck sealers. Is again, we wanted to come up with a fairly effective way instead of using just a nozzle with a sprayer. And so we developed, again, worked with NDOT, and actually they took the lead on this one in one of the districts and modified this sprayer system onto the back of a truck that we could now load it up and essentially coat an entire bridge deck in a matter of minutes. So this is another way. So again, we wanted to take it out of the lab and bring it into practice here. So just a few recommendations is we feel that the combination of the crack and deck sealers are most effective. In fact, what's most effective is, again, to start doing this from when the bridge is built. Originally, you're going to get through-depth cracks that develop. We like to maybe wait a year and get out there and seal those cracks, let them widen a little bit, and then seal it. And then also to get that whole deck sealer on as soon as possible so that we stop the chlorides from getting in. And this is something we should do for the life of the bridge. Sealing the cracks using a combination of products, as I mentioned. We found that for the epoxies, the larger cracks, if they're about 0.16 inch and greater, epoxy is a great material for that. The finer cracks, even with super low viscosities, methacrylate seem to work better for us, and that kind of relates to what we were talking about earlier. Resealing is something that ought to be definitely considered to continue your effectiveness, and so we came up with about a 5 to 10 year. We felt about 10 years is probably right for what we saw in the study. But if you have high volume traffic where you're really getting much more wear, a 5-year interval seems more appropriate. So I think it depends upon how much your traffic is on the surface. One thing to mention, and this is about water-based materials. So as we're going more environmentally friendly, the one problem with a water-based product is if I'm trying to seal something that is now trying to resist water, you're not going to get penetration in. And so that is something to think about of what products you have, because you locally may get some because you have wear localized, and it may penetrate one area but not the other. So you need to actually, if you're going with something already had it and you're trying to use a water-based, so initially it could be all right to use a water-based, but future ones, water-based really doesn't work effectively unless the surface is prepared where you remove the old sealer. So it's something to think about as you move forward. So with that, I'd like to have any questions if there's a few minutes. I would mention that the report, there's a detailed report on this project. It's available on the JTRP website, Joint Transportation Research Program. There's the web address, and if you just either look up my name, you'll find it, but it's under Bridge Deck Preservation Program, the complete study.
Okay, maybe I missed it, but just wondering, did you cycle maybe you said this, but did you cycle the cracks open and closed after sealing them at all?
Yeah, so we didn't continue to cycle longer term. We actually sealed the product, and then we stressed it after to 40 KSI in order to make sure that whether it was, if there's bond, or is it just filling in the crack, or is it actually bonding to where you now don't get a new surface that's happening between it. So that's what we did. We didn't cycle throughout the whole testing program, just that. But of course, the cycles of salt water were happening every 2 weeks on a 2-week cycle.
Just curious to know why you only selected those 3 products. I mean, was the thought to develop an approved product list from the test, or was it those 3 products already on the APIL, and you wanted to test those viability of those
Yeah,
three.
so we had a previous study, again, it's on our website, that evaluated over 200 and some products. These products were all at the top of our performance of the previous study that tested several, I don't know, I say we probably did 50 some in the lab. And so they were top performers, but they were also already on the approved product list for NDOT, as well as many other states around the region. And so we went with those that we knew were already top performing to see how they would do in terms of this resealing applications and things like that. We tried to develop some standardized things about the chemistry of certain products, whether they work or not. The one thing that was difficult with that is we had some that essentially were identical products before that were tested, and performance varied widely on identical products. So we went in this part. This was a study that started very big, and the pyramid went down to where we were actually just focused on trying to develop what is the system protocol for them to install this, get it out in the field, and start showing good performance. But we're not trying to restrict from other products. We have an approved product list that has other products on it.
Yeah, I got a question. My name is Larry Woletsky with Minnesota DOT, District 6 Bridge Maintenance. My question is, I know the methacrylate will soak right through, drop on the highway if you don't plug the bottom. But what was your average depth of your penetration on your Secador and the other product for your crack sealing?
Yeah, so this is 8 inches.
But those two products went through the rebar?
Yeah, yes.
Okay.
Full depth, it went through.
All right. Thank
Yeah,
you.
we also, again, in autopsy, we could validate that as we cut the bars out to see if they were sealed. So that SLV is, super low viscosity. It actually did perform very well in terms of getting into penetration. But again, it depends on your crack width.
I'll be real quick. When you showed this, you crack sealed, and then you put the sealer, you put the flood coat sealer. Is it critical that you do it in that order, or can you seal the cracks after the silane has been applied?
Yeah, so in terms of what we're doing in new is generally we can get the silane on first earlier because the cracks they're shrinkage based, right? So if we could seal that first. So we have not, said that we can't do one or the other. I mean, in some ways it would be nice, you say, well, I get the crack repair first because I don't get any other chemistry involved with that bonding to the surface. But we didn't, haven't noticed any issues because those seem to penetrate in, but we still get the roughened surface from the bond too. There's also some delay in time before when, we're actually doing the first repair. The one thing I didn't mention in this study, because the study had a lot of different other aspects and I only had 20 minutes to talk, but we also looked at resealing. So if you would have something that's deteriorating down 3 years and we have a lot of corrosion and tried to reseal, and we saw that the rate of corrosion did change, and so it reduced, but it did not stop the rate because we still had a lot of moisture already inside and all the chlorides were inside. So unless we can fully stop that moisture, we can't stop it, but it did reduce the rate. And so it had some enhancement, but it's not a cure-all saying, oh, I just put a silane on now and it's going to stop all my corrosion.
The preceding video was produced by the National Center for Pavement Preservation. More information can be found at tsp2.org. That's tsp2.org. Additional support provided by Michigan State University.